The parallelogram law is used to find the resultant of two vector forces at a time. To find the resultant of two concurrent forces drawn as directed arrows, a parallelogram may be constructed using these two forces as the sides. The diagonal of the resulting parallelogram, drawn from the point to the opposite vertex, represents the magnitude and direction of the resultant of these two forces. Let us demonstrate how to use the parallelogram law to solve for the resultant of this force system. Remember that the parallelogram law can only be used for two forces, that is concurrent. But for this example, you can see that we have three forces, although they are concurrent, meaning they are meeting at a common point. So what we are going to do is we will isolate these two forces first and solve for its resultant before we will use that resultant to solve for the resultant of the total force system. So what we will do, let's isolate forces A and B first. So let us copy this first side. This is A, equal to 10 newtons, and the other force will be equal to 15 newtons. To construct the parallelogram, we will copy this force should look like that. Its magnitude is also 10 newtons, and copy the second force with the same degree or angle and direction. This is also 15 newtons. Now to find the resultant, that should be starting from the starting point of these two concurrent forces to the opposite vertex of our parallelogram. So this is our resultant force. Let's name that RAB, or the resultant of forces A and B. Now, force B is inclined 30 degrees from the horizontal, so this should also be inclined at 30 degrees. This is a supplementary angles, so the sum of these two angles should be 180. 180 minus 30 should be 150 degrees, and this is 30 degrees. So let us isolate this triangle. We have 10. This is 15. And the resultant is RAB. This is 150 degrees. To find the magnitude of the resultant of A and B forces, we will use what we call your cosine law. For cosine law, let's say we have a triangle. This is, let's call this side A, side B, and side C. This is not necessarily 90 degree. So let's name this angle theta. Using the cosine law, we can solve for the magnitude of this side C if we know the values of A, B, and theta. C squared is equal to A squared plus B squared minus 2A B times the cosine of the angle opposite the side that we are looking for. So using the cosine law, we can solve for RAB because we know the sides A and side B. So using cosine law, we are curious about the resultant. This is RAB is equal to the square root. If you take the square root of both sides, you will cancel the square root of the left portion of your equation. So this would be, your A is 10 squared plus 15 squared minus 2 times 10 times 15 cosine of your angle 150 in degrees. So we can solve for the value of RAB. RAB is equal to 24.18279.597 units will be in newtons. But that is just the magnitude of the resultant of force A and B. We need to find the direction of that resultant or the angle of inclination from the horizontal. To do that, we will use what you call your sine law. So using sine law, if you have a triangle, this is RAB, force A and force B. This is angle theta. Let's name this angle alpha and this one angle beta. Using sine law, RAB divided by the sine of the angle opposite that side is theta is equal to A over the sine of the angle opposite it, alpha, is equal to B divided by the sine of the angle opposite that side is beta. So we have the value of RAB, that is 24.18279, so on. And we have theta to be equal to 150 degrees. We also know the values of A and B. This is 10 and this is 15. We can solve for the angle beta or alpha. In the figure, this is your angle beta. So we can solve for the angle beta for us to know the direction of your resultant AB. Your beta is equal to, or sine beta, using cross multiplication for these two expressions, that would be B times sine of theta divided by RAB. Continuing, we have your sine theta equal to B sine of theta over RAB. We know the value of B to be equal to 15 newtons. Sine of theta is 150 degrees divided by the value of RAB. This is 24.182, so on. Let's just save this value. So, beta is equal to the arcsine of 15 sine of 150 divided by the value of RAB. So beta is equal to arcsine 15 sine of 150 divided by RAB. This will be equal to 18.06753729 degrees, or 18 degrees 4 minutes 3.13 seconds. So the resultant AB is equal to 24.182 newtons measured 18 degrees 4 minutes 3.13 seconds from the horizontal. Or 18 degrees 4 minutes 3.13 seconds north of east. So that is the resultant of forces A and B. We can now change these forces A and B into its resultant. So this is already your resultant AB, that is 18 degrees. This will be RAB. This is beta. Let's write beta at the upper right corner. Beta is equal to 18 degrees 4 minutes and 3.13 seconds. So that would be your resultant of A and B. This is 24.182 something newtons. Okay, we already have your two forces. We can further use your parallelogram law to solve for the total resultant of the three forces a while ago. And to do that, you will construct another parallelogram using these two forces. We have an upward force C equal to 10 newtons and your RAB, this is RAB. We will construct a parallelogram. Copy this force. This will be 10 newtons still. And the other side of your parallelogram, this will be also RAB. To construct your resultant force, that should be from the common point to the opposite vertex. Let's call this your total resultant. So, if this is beta, this is 90 degrees. The sum of the interior angles of triangle is equal to 180 degrees. So 180 degrees is equal to, this is 90 degrees plus the angle beta plus this angle. Let's call it angle X. this is angle X. To solve for angle X, that is equal to 180 degrees minus 90 transpose minus the angle beta. So the angle X is equal to 180 minus 90 minus beta is 18 degrees, 4 minutes, and 3.13 seconds. So this should be equal to 71.93246.389 degrees. We need to look for this angle. Let's call it angle gamma. Since these are supplementary angles, its sum should be equal to 180 degrees, and that is 180 equal to angle X and angle gamma. We know the value of angle X. Your angle gamma is equal to 180 minus the value of X. Gamma is equal to 180 minus 71.93246.389. So this will be your angle gamma, 108.0675.361 degrees. Alright, let us now isolate this triangle for us to solve for the magnitude of R. If I isolate that triangle, you know this side and this side, we can use cosine law. Your R now, I will record the angle gamma here. It should be 108.0675.361 degrees. So I can delete this one. So using cosine law, the side that we are looking for, R squared, is equal to RAB squared, this side, plus C squared. This is equal to the 4C minus 2 times RAB times C cosine of the angle opposite the side that we are looking for, that is gamma. So to solve for R, that is equal to the square root of RAB. You have this value to be equal to 24.182 plus 10 squared, that is C, minus 2 times RAB times 10 cosine of, should be cosine of gamma, 108.06 degrees. Okay, let's calculate that. Square root of RAB squared plus 100, that is 10 squared, minus 2 times RAB times 10 times cosine of the angle gamma. So the total resultant has a value of, or magnitude, equal to 28.89303743 newtons. That is the magnitude of our resultant. For the direction, we can use your sine law. We need to find this angle, and let us name it angle phi, such that if you isolate this triangle, R divided by the sine of the angle opposite it is alpha, is equal to this force, that is 10 newtons, divided by the sine of the opposite angle. Opposite it in the triangle is the angle phi. We can use this to solve for the angle phi so that we can know the direction of our resultant. So if you use this one, you know this value 10, and gamma, you also know this value. You can solve for the value of angle phi. That is just equal to the arc sine of 10 sine of gamma divided by the value of r. So we have your angle phi, that is equal to arc sine of 10 sine of gamma. Your gamma is 108 degrees, and your r, or the resultant, is equal to 28.89 newtons. So we have your angle phi. This is equal to 19.21041,498 degrees. Okay, let's copy these values so we will not lose it. We have your total resultant equal to 28.89303743 newtons, and the angle phi is equal to 19.21041,498 degrees. So we have the magnitude of your total resultant, but the direction is not angle phi. That should be measured from the horizontal, so we can easily express it in terms of north, south, east, west. So this should be, let's call angle phi plus angle beta, so it will be measured from the horizontal. Let's call it epsilon. So angle beta is 18 degrees, 4 minutes and 3.13 seconds. So epsilon is equal to 37.27795,109 degrees, or 37 degrees 16 minutes 40.62 seconds. So we have your total resultant of magnitude equal to 28.89303743 newtons, measured from the horizontal. That will be 37 degrees. We can write it as 37 degrees 16 minutes 40.62 seconds north of east. This is your east direction, this is your north direction, so that is this angle north of east measured from the horizontal. That is your total resultant using parallelogram law. Take note that using parallelogram law should only be done when you have two forces that is concurrent to each other. If If there are more than two forces, you need to isolate two forces at a time so you can solve for the total resultant. Thanks for watching. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.